Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right, so good afternoon, everyone. For those that I haven't met at Microtrail, I'm an intern here for the summer, working under Ralph Herbich's group, the Online Services and Advertising group. And my advisor, Professor Richard Hahn from the University of Colorado, is here to talk about some work that we've done on a project called Social Fusion.
Thanks, Mike. Well, glad to be here. This is a topic that I'm going to be talking primarily about at sort of high level. We don't have a full implementation yet of everything, and so it's more sort of a futuristic direction that we've been exploring. And it's all about trying to fuse together mobile, sensor, and social information to help sort of enable next generation context awareness. And this is work with a bunch of PhD students, including Mike, and some faculty as well. My background is primarily in mobile systems and wireless sensor networks. And we have been noticing, of course, in mobile and sensor networks, a huge surge in popularity on these type of systems, and in parallel also a rise in popularity for social networks. And we think that all three of these are going to give rise to a much richer environment of context awareness, where applications can be customized much more precisely than they are now to what you're interested in. And there has been some work in the past on context awareness, certainly in the 90s and even now in ubiquitous computing. But much of that earlier work came before the advent of these major trends. So social networks weren't really around in the 90s. Mobile smartphones have just really seen a big growth since the iPhone was introduced in 2007. And sensor networks, of course, is an area that I like. Wireless sensor networks have sort of just the last decade have really grown in popularity, at least in the research community. And so all three of these trends are rich sort of veins to mine for context. So for example, social networks provide you two classes of information that describe who you are. Basically, what my likes are, what my hobbies are, my favorite bands, my favorite movies. All these preferences are listed on a lot of our profiles, as well as who am I friends with. So sort of two different classes of information there, and they describe a lot about who I am. Mobile networks, there's been a lot of work on location-aware applications where they use your GPS or some other Wi-Fi localization, whatever technology, to tell you where you are. But actually, recently there's been even more work trying to mine the additional sensors that we have on these mobile smartphones to give you even further context. And so, for example, some work out of Dartmouth has been looking at activity recognition by looking at accelerometer information, listening to the microphone, trying to infer what activity you're actually currently in or undergoing. And that's additional context information that may be helpful. And then, of course, sensor networks provide information about the ambient environment, with the lights on, who might be in the room, that kind of thing. And of course, I'm here at Microsoft. I just got back from the Microsoft Faculty Summit about a week or two ago, and there's a lot of, justifiable sort of, I think, pride in sort of the Connect. And this is a very rich multimedia sensor. At least I would characterize it as that. And so that provides additional contextual information. So sensor networks are not just these small mote class devices, but can also be quite complex. And we think all of these are driving us towards sort of this vision of context-aware computing, where the cloud, which is a fourth major trend that's happening at the same time in parallel, will be where we do all the fusion of these different streams. Out of this fusion, we're going to be getting a whole new class of sort of, I think, context-aware applications. How many of you have seen Minority Report? Okay, so everybody, pretty much everybody here. So there's a part of it where, as Tom Cruise is walking through the mall, the mall senses who he is, sort of knows a little bit about him, and starts to project, in this case, an ad on, the screen saying, "Hello, Tom," and so it's customized to him, and the multimedia environment instantly sort of morphs to what he's interested in. If you think that this is a little too creepy, then or too intrusive, there are, I think, other classes of context-aware applications, such as mobile health. If I walk into a supermarket, can I be informed because I have allergies against peanuts that I should definitely not buy this product, even though it doesn't say on its ingredient list that it has peanuts. So we can certainly develop tailored mobile health applications as well that are, in this case, very context-aware about our individual sort of health situation. We've also all heard about some of these mobile social networks. These are in sort of a class. So those are sort of individually customized or tailored context-aware apps. We also are starting to see the emergence of sort of group-based sort of context-aware apps, and mobile social networks are one example. Foursquare, Facebook has added location features, as has Twitter, etc. And so certainly there you can see where your nearby friends and that kind of thing. But we think there's actually a whole new class of context-aware apps that are interesting to explore from a research perspective, and I'll talk a little bit about mobile social video, mobile social audio, and mobile social brainstorming that we've been sort of playing around with in our group. And we're using this sort of to try to explore different pieces of that social fusion vision. And so essentially our social fusion project is to try to figure out what this cloud in the center is. And try to sort of make some progress on building out some of that infrastructure. And so based on our experience playing with different apps that are mobile, social, and all that, this is what we envision to be what makes sense to us, at least. So we're going to have different information streams, largely social, sensor, and mobile. And they're going to be sort of gathered and collected in some sort of database. It doesn't have to be sort of a centralized piece, but it could be very much distributed. And on top of this, we'll have a sort of class of sort of inference or data mining that's going on. And this is actually could be composed of multiple sublayers. So for example, there's been some work on inference of like affective computing, where you're trying to determine the mood or the emotion of people. And so you may be taking into account lots of different streams and making sort of a first layer inference. Here's a face, here's a nose, here's a tone of a voice, and then a second layer of inference built on top of those first layers that are ultimately determining maybe the mood of the person. And then that is used later on in what we would call sort of our recommendation or actuation layer, where we actually do something with that information. We play a video or some audio stream, or we turn on the lights, or we change the ambient heating, that kind of thing. So really just 3 layers, and inside of each one of them, really multiple sublayers sort of composing web services together. Okay. One of the concerns that has arisen in our initial investigation here is that privacy is, of course, a big issue. That's a question we always get. And really what we're sort of drawing here is that we're probably going to need privacy filters throughout this architecture for all of the major substreams here. And so the aspects that we've been exploring, we haven't, as I said, built out this whole vision. We've been exploring individual pieces of this, so we've been primarily looking at the mobile and the social pieces so far. And even though I come from a sensor networks background, we haven't strongly intertwined sensor networks yet into some of our research. We've been looking at privacy issues, but only in the context of the single information stream for social networks, but of course we would like to expand to other sort of privacy streams. Certainly there's been work on sort of location-aware privacy. A lot of work has been done to sort of mask your location. And we've also been, as you'll see, we played around with some of the data mining inference and recommendation just to sort of get a feel for what this might look like. Okay, so if we examine each one of the individual streams, we already see progress. People are focusing just on social, for example. So a whole new class of socially informed applications is emerging with increasing integration of Facebook and Twitter into their online and mobile apps. So you can easily sort of say, for example, you can post to your Facebook account that you like this news article, something like that. And of course, Microsoft and Google are going one step beyond that. They're making search more social, and I think news more social, if what Mike tells me is correct as well. And I'll describe briefly some work that we've been doing at Colorado on sort of social news. And then I'll also describe the work on context awareness that where we sort of prototyped a mobile social jukebox or mobile social audio, mobile social video, and mobile social whiteboard. Okay, so that's sort of, if you're just looking at the social stream, how you can sort of enhance applications by just using social information. You can certainly enhance applications by just using mobile information as well, and there's been progress in that regard as well. What essentially people do is take advantage of the different sensors on the phone to enhance their applications. We already know about location-aware applications. We see them all the time. More recently, augmented reality apps have been appearing, like the Layer browser and Yelp Monocle, where as you sort of orient yourselves, you can see an overlay on reality of some additional sort of tags that describe what you're looking at. And so these are orientation-aware. Accelerometers are being used as well for games. And then mobile video apps are increasingly more prevalent, like Apple's FaceTime, that can use the front and or the back cameras for your mobile phone. And then, of course, it's only a matter of time before we start using some of the other sensors like light and proximity as well. And as I mentioned earlier, some people are starting to combine and to use multi-dimensional sort of sensor data to infer activity. Okay. And then the final stream is sort of just the sensors themselves, fixed sensor networks. This is a rich set of applications, and they can provide information about whether the light's on in the room, simple contextual clues like that, and all the way up to more sort of advanced emotional sort of inferences. So camera networks, for example. And as part of that, Connect is part of this new wave of really complex sensors. Okay, so Social Fusion is about fusing all three of these major streams. Some of the early work in mobile social networks kind of misses out on sort of fixed sensor networks and what they can do. And so I don't think it has fully realized the potential of context awareness here. And so it's up to us to really explore this area and maybe invent the next killer mobile sensor social app. It starts to become a mouthful there. But I'm actually thinking that, as a systems researcher, I kind of like building infrastructure and protocols. And I'm thinking that this might be the case where it's like we're in the early 80s of the internet, where they built a lot of infrastructure, IP routing, TCP, HTTP, DNS, whatever. Well, not HTTP, but like DNS. And so some of the early infrastructure that will enable sort of next generation killer apps there. And so I'm kind of excited about some of this infrastructure stuff. Okay. So then let's look at some of the apps that we've prototyped. I'm not going to get into a lot of detail here, but mobile social music jukebox. So the idea is that if you walk into a bar with your friends, the bar recognizes who you are, can go look at your Facebook profiles for hints about what you like, and then synthesize a music playlist based on that kind of information. And so it's mobile in the sense that it knows where you are, in this case through by detecting your mobile location. And this can be accomplished in a variety of different ways. I think in our prototype we use Bluetooth, but I mean you can use a check-in model, you can use sort of publishing your location periodically on Facebook, something like that. We also need a handle to who you are, which will allow us then to retrieve information about you through the Facebook API. We're primarily playing with Facebook, but we could play with Twitter as well. Facebook is convenient. And then we would synthesize sort of that information and then go out to maybe a service, Web 2.0, whatever service, to retrieve a playlist. Okay? But we actually probably have to do some additional thinking here, because if we have multiple people in the room, we have to figure out how to fuse together their different interests to come up with a playlist that sort of most pleases, I guess, the group. And so that's actually some interesting things that we stumbled onto when we were trying to build this mobile social jukebox, if you will. The first, if I'm the only person in the room and I haven't given access to any of my MP3 library, I've only given you access to my social profile, which might list some bands that I like, but might not. Might list that I like hiking and biking and Shakespeare, let's say. So how does that, if I list hiking, biking, and Shakespeare, how can I generate a music playlist from that? I mean, it's not necessarily obvious, from that. And so how do we generate a playlist for a single person is one challenge. Then if there are multiple people in the room, how do we reconcile their potentially conflicting interests? If one person likes classical, another person likes, hip-hop, how do we combine those? So these are all sort of subjective, and in fact, a lot of this context awareness starts to become, you have to sort of very much start doing many human studies. And I'll talk a little bit about that later. So that's a mobile social music app. Here's a mobile social video app that actually Mike built called Social Aware Flicks. It's doing the same thing. So the architecture looks very similar. When you walk into a room, if you've got a video monitor or screen, it automatically adapts its content to you. Okay, and so it will play you what you want to see. And so this might be interesting, like for example, in a sports bar where you and your buddies arrive and you want to see the game, and you park yourself in front of a screen. It automatically senses that you're all fans of, I don't know, Manchester United or Chelsea, and so it'll automatically switch to the game that you're interested in, and so this is what we were trying to prototype with Social Aware Flicks. In this case, we were trying to show a video that a movie that all of them might be interested in watching together. And so again, we are using social information, mobile information, and some back-end web services, in this case, the Netflix movie recommender. Okay. So I've already sort of gone through this architecture picture, so I'll just skip this. Okay. So we face challenges, as I said, in terms of just the context-aware part. How do we generate, these playlists? So, for example, this illustrates some of the issues. If on my Facebook profile I listed that I like Matrix Revolutions and Mission Impossible, this can be used as input into the Netflix movie recommender, which might come back with, a set for each one of my favorites that I've listed, recommended movies to watch. So then there's a question of, well, for a single individual, then, all right, we can sort of put all these together. What metric do we use to reorder these to show the movie that would be most pleasing to that individual? Do we use sort of release date to show the most recent movies that they may not have seen, or do we show, you know, the star rating, the highest rated movies first? We don't know. So just for an individual, it starts to become kind of interesting. And even here, how you fuse together from each one of the individual favorites, your sort of aggregate list starts to become kind of an interesting question. You may, for example, want to preserve diversity, and so instead of sort of fusing them all together, you might say, I want to keep a couple from each one of the original favorites and have that sort of propagate through to the end, if you will. And so that's just the problems that we face when we have a single user. And then we ran into the problem, because it's a social aware Flix app, how do we do this for multiple people? So assuming that we've solved all those problems for a single individual, now we have Mike and Fred, and we can all generate sort of recommendations for each one of them. But now Mike and Fred, we want to analyze sort of how do we come up with a group recommendation that would most please Mike and Fred together. And so there are different ways that we can do this. One way is just to sort of look at, let's say, for example, the highest rated movies in Mike's list and the highest rated movies in Fred's list, and only take those and then present that as the playlist. But another way is to sort of analyze the content of those favorite movies. So the first approach doesn't even look at sort of content, and says, you know, Mike actually likes a lot of comedy movies, as does Fred. And so this might be something that we can glean from doing some more deep data analysis. And therefore, comedy is the dominant theme, and so we're going to recommend comedy films in the final aggregate. Okay. So this is some of the things that we ran into when we were trying to prototype the social aware Flix. I can't say that we have, you know, great answers to any of these problems. These are just more like questions that we ran into. And this work actually helped stimulate what I'm going to talk about next, which is our group paper from 2010 on enhancing group recommendation by incorporating social relationship interactions. So the prior work on social aware Flix didn't really take into account, it was only weakly social, because it was looking at things like, oh, you know, we're looking at the content of people's favorites, and so we were only looking at, you know, comedy films. You know, we extracted that information. But we didn't know whether Mike and Fred were good friends or not, or whether they were like siblings or what, you know. And so we didn't have any sense of the social relationship between these folks. And so we thought that it would be really interesting to investigate how social influence and the relationship between the different group members. Are they all strangers that are meeting for the first time? Or are they a husband-wife couple? Or, you know, is it some friends who are getting together on Saturday night? You know, how can we sort of use these indicators to help us give a better group recommendation? And so what I'm showing here is essentially sort of what we were investigating. And so a lot of work has gone on individual recommender systems, and so we're fine with leveraging some of that. And what our contribution or interest was the consensus function. How do you fuse together and decide on a group recommendation when you have all these individual recommendations? And our idea was to use social group descriptors, indicators of the ties between the different members of the group, and so so we embarked on trying to understand what this kind of consensus fusion function or ensemble function would be, and I feel that we did make some progress, though by no means did we answer all the nail down all the questions, but we had to we had to actually interview people, and we're systems folks, and so we're not necessarily the best at doing user studies. So take what I'm about to show you with a grain of salt. But we did extract some interesting trends. So let me describe sort of what we found. There has been prior work on group decision making, investigating that, and roughly speaking, the kinds of group decision strategies that have been uncovered are average satisfaction, minimum misery, and maximum satisfaction. So the way that this would work is if Tom and Mike have individually sort of rated a movie, like, let's see, 3 and 5 for Tom and Mike for The Matrix, if the average satisfaction approach holds, then you would average these, and you would predict that the group would, when they got together and they talked about the movie, that they would come out with a sort of, maybe Mike's might go down a little bit and Tom's might go up a little bit. And so this is average satisfaction. Minimum misery is when, if they get together and they talk about it, they decide, that really was a terrible movie, and so they tend to go towards the most negative. And then maximum satisfaction would be when they tend to bias their group decision towards the most positive. Okay, we actually found indications of all three kinds, and it depended on how social the group was. And so you can't just apply those previous group decision strategies in a blanket way. It sort of depends on these more fine-grained contextual clues that we've been trying to extract. So for example, so one of our contributions, we came up with a social descriptor. This is basically trying to measure how strongly connected are the people in the group to each other. I'm not going to get into too many of the details here. And we also have an expertise descriptor that's trying to measure, if one person in a group is has much more expertise. Maybe they've watched 1,000 movies. And so in certain situations, people may be willing to defer to the leader, if you will. So there's sort of this leader syndrome that's also been investigated. And that's partially reflected in this expertise descriptor. There has been early work on also looking just at content, where people look at sort of how similar are the content interests that have been expressed between all of these different folks. This is called average pairwise dissimilarity and variance dissimilarity. And so what we do is these are not really looking at things like what's social, how strongly connected are these people. So we will compare to this a little bit later on. And so what we found, these are just sort of trends, and this kind of illustrates what happens. I don't think these were actual numbers, but that if the social tie was, let's say, between a husband and a wife, so that's a pretty strong social tie. So maybe let's say user 1's the husband, user 2's the wife. We found that in our interviews at least, the eventual consensus that they came to in rating was the maximum satisfaction. Okay, and I think that was because they were sort of deferring to each other, and sort of getting along with each other is very important. So in husband and wife, very tightly coupled, we got that information, or we got that kind of behavior. When friends who are more loosely coupled, we got sort of an averaging effect. And then when strangers were together, we got sort of this minimum misery sort of effect. So depending on how strong the social relationship was, you have sort of different. You would use a different policy for group recommendation. And we also we measured expertise and similarity as well. And for expertise, it sort of behaved kind of like I don't know how you would even describe the expertise. How would you describe that, Mike? Is that more like a maximum? I guess it was, if this user 1 is the expert and user 2 is the non-expert, then the group tends to follow the expert's advice. Okay. So given all of this sort of, this interview sort of data, we went ahead and created a function, and this is sort of this scary function. But all it's really doing is saying, if our social strength is really strong, then people behave with sort of a max satisfaction. This is the husband and wife situation. If you're friends, then you sort of do an averaging, and if you're strangers, then you wind up, your behavior would be, your group consensus behavior would be towards the minimum kind of thing. And then you would sort of have the way we incorporate expertise in here is to modify the individual rankings of viewers, multiply it by the expertise of that person. Okay, and so I can't remember exactly how we incorporate the dissimilarity. So anyway, this was a heuristic that fit our data well, but we also wanted a more general sort of way than the heuristic to figure out, in any general sort of case, can we sort of derive rules? And so we came up with a more systematic approach using associative classification. And an example of that is we're essentially looking for frequent item sets or patterns in the data. So it could be the case, so we were using the FP growth algorithm, and so it could be the case, for example, that you notice that every time the social strength is strong and the max rating is 4, that the group rating winds up being 4. And so you would extract this rule from the data that you would get from like user studies, that kind of thing. And so this is a more systematic way to sort of derive sort of rules. It's more probabilistic, if you will. And we went ahead and then subjected, after we had interviewed all of this, we went and evaluated and looked at the performance of our systems. And so we had just about 30 people that we were interviewing to get sort of the ground truth on this. And this graph is really just showing, is just quantifying sort of that when you have a strong social strength between a couple, the best approach was maximum satisfaction. When you had medium sort of social strength, the best approach seemed to be average satisfaction. And when you had almost very first acquaintance strangers, the best function seemed to be a minimum misery function. So ultimately, at the end of the day, we wanted to compare our recommendations, both for the heuristic and for the more systematic FP growth approach, to the state of the art, which was not using any social, it was using the pairwise dissimilarity metric. Okay, and so the pairwise dissimilarity approach, so we were looking at sort of the number of stars in the movie that was recommended and how different that was from the group consensus, the ground truth. And so the mean difference for average pairwise dissimilarity was about 0.87, but you see that we have a lower number of sort of, we're closer to the truth by using heuristics, and sort of in between is the rule-based approach. Based on our understanding, we were hoping actually that the more systematic rule-based approach would do better. And we think the reason is because the rule-based approach actually needs a lot more data to build the rules properly. And so we only had about 30 people's worth of data. So we think that over time the rule-based approach will be better. In any case, both were an improvement upon the baseline, which was what we considered the state of the art. Okay. So this gives you a sense of, how difficult, there's a lot of effort that's when you're trying to do context-aware research. You got to interview people and do things which might take you outside of your comfort zone. Okay. All right. So I'll just skip this. Another context-aware app that we looked at was WikiWalker, which was a mobile social whiteboard. And the idea here is that you would combine together, again, your location and social networking information when you are standing in front of a whiteboard. And most of the time when you're in front of a whiteboard, the goal is to brainstorm. You want to come up with new ideas for research, a new project for your class, that kind of thing. And we thought, wouldn't it be great if the whiteboard could suggest ideas to brainstorm or on based on information about you? So if you're interested in hiking, or if you have expertise in security, it can actually pull that. It doesn't have to be from Facebook. It could be your LinkedIn, a professional profile. Or it could be, if it knows what your name is, it can look at your author list and that kind of thing. And so pull information that would then recommend ideas to brainstorm off of. And again, this is mobile and social. So, and we presented this at a workshop at the group conference. Okay. And so the final context-aware app that I wanted to mention was social news. And I know some folks here at Microsoft are exploring this topic as well. And so the idea here is, we're not playing with the entire Social Fusion architecture. The pieces that we're touching on this particular project are sort of this part of the cloud, as well as just the Facebook data stream. And so the idea that we were looking at was how to improve social news recommendations. Google News and Bing News all sort of provide a list of recommendations and use advanced algorithms to try to give you good news topics, collaborative filtering, other types of recommendation. But we thought we could actually improve upon this by leveraging social information. And that includes the personal interests, also interest about who your friends are, that kind of thing. So somewhat similar and motivated by some of our earlier group work. So we think that we can add some subset of to the current news recommendations, things that are of course based on your personal interests, derived from your Facebook likes, but also maybe derived from, we saw social strength earlier. This was the example that we were sort of bringing up. We might care about what's going on where my wife or where my husband or my parents live, okay? And we can find that from Facebook profile information if people fill it out. And so the idea was that we might care about, what kinds of stories are affecting, them back at home, Or if it knew where my hometown was, it might provide, some recommendations for stories from my hometown that I would be interested in, that kind of thing. And this can be mined from, your social network information. Then we thought another class might be, we might like to see stories from, recommend news from our most similar friends, maybe our buddies that we go rock climbing with, that kind of thing. So this is a sketch of the architecture that we've been working on for social news. It's essentially taking three streams. The first, we're essentially taking information from Facebook over here. We're mining that. And the first stream is really your own stream. From your own Facebook profile, we have a way to sort of rank your Facebook likes. And then from your Facebook likes, we can compute news recommendations by passing that to the Bing search engine and getting some results back. So then what we do is we look at your friends, and then we say, okay, your friendship information, we have a module that does what's called social strength ranking, and another module that does user similarity ranking. And then we pass these again through our Facebook like ranker to compute a bunch of different articles, and then we fuse them together using this ensemble piece here. The other, I think, innovation here is that we're using this click-through to actually modify all the way back towards the beginning and throughout, including the ensemble function, how we are actually, it should be the case that the more that we click on, let's say, information that comes from social strength, we should actually start seeing more articles that arise from social strength, produced recommendations. And so that's what we're essentially doing, is we're trying to generate a feedback system at three different levels that is responsive to the clicks of users who are getting these news articles. If we just look at one of those boxes, for example, this gives you a sense of it's more complex than we actually originally thought. And so, for example, how do we compute the social strength? The subsystem actually takes into account a variety of different factors, including your relationship status, who you've been tagged, whose photos you've been tagged in, where you've checked in, who's been writing on your wall, geographic proximity, what joint groups do you belong to with your friends, and what kind of family relationship might you have with the friend. And then we would then sum these scores together to get a sense of how strongly connected you are. And so we are actually, this gives you a sense that it's a very multidimensional problem. Okay, the click-through, I guess we already sort of mentioned. And for example, if a user begins to click more on topics generated by social strength, then we would weight that stream more aggressively in the future for future recommendations. Okay, so our status is that we initially did a sanity check just to see if it would make sense to use, social information to, what did the results look like? And so we passed these through Bing, and we took the first 5 likes from 20 of the best friends of Mike's, and I guess you could say that he liked the results. So that was our initial sanity check. They appeared to be more meaningful, but it was subjective, granted. And so since that time, we've been sort of implementing various pieces of the system. We don't have the whole thing built yet, but we hope to have a tech report out within a week describing how we actually do this. And so our focus on sort of the immediate future is to actually synthesize the complete system, deploy it on Facebook, actually, as a Facebook app, so people can download and install it and start getting social social news articles. And in that way, that'll actually give us, hopefully, some ground truth, and we can get a lot of data out of this. So if you actually can help us and install this app, we'd certainly appreciate it. Okay. All right. So the final topic, and I guess I have 3 to 5 minutes to finish up, is privacy. So I won't go into great detail. We had a publication at SocialCom talking about rethinking anonymity in social networks. And the basic truth is that there are 500,000 Facebook applications out there that want access to your data. So that's and they all want access, in different ways. And so usually when you install one of those apps, they ask you, can I have access to your data? And you say yes. And that's sort of it, yes or no. And so we think that there ought to be a layer between you and some protection between you and all those 500,000 apps, more than just clicking yes or no. That we should be able to quantitatively anonymize or describe or filter the information that's being released, and quantitatively be able to measure how much information is being sort of leaked out from your profile. And if you look at some of the previous work on sort of k-anonymity and all that, it's primarily designed for these huge health record information sort of databases or data sets, and you release all that information at once. But in a Facebook or sort of social network API, you never release all the information all at once. You make a single query on a specific user or a specific sort of subset of users, and you get a small amount of data back. You don't get the whole darn thing, and you don't have to anonymize the whole darn thing. And that's what some of the prior work has been sort of focused on. So we've developed something called QAnon, and the way that it fits in the context of social fusion is that it's really focusing just on anonymizing social network information. And so I won't get into too much detail here. I'll just say that what we're trying to do is come up with a metric. So if you can imagine that this is your Facebook profile, or this is what is really in Facebook. Maybe it lists your college and your birth and what movies you like and where you're currently located. Okay, and someone does a select on this, trying to find movies from people who are within a certain location. So this is a mobile social query. These are all the possible matches for this, and you can release all this information. But what if? And the question that we asked was, what if you wanted to sort of anonymize this and withhold information selectively? How can you even measure how much that helps you? And so, for example, in this, rather than releasing every single movie, we release Avatar, Titanic, and Terminator, okay, in the hopes that that sort of hides us a little bit. And so the person who issued this, or the Facebook app that issued this query, will get some information, but not the whole shebang. And so we came up with a systematic way to evaluate what is the cost of how hidden is my information based on all the information I could have released. And so we looked at all the possible combinations that could result in this case, this release of data. And for example, Avatar, Titanic, and Terminator could be user A and user B combined. They could have resulted in a hit that would have released this information, that kind of thing. And then in addition to that, we examine, of all the different sort of combinations, who is the most common. So if A was the most common and was in every single one of the possible matches, then A would be compromised, without doubt. And so the most common user that is sort of the one who's at most risk of being exposed if you were to anonymize in this particular way. So we developed a metric called Q. So what it does, so here's the original query, here's the database, here's our choice for anonymization. How do we systematically sort of do this? We say Avatar could have come from A, C, or D. Titanic could have come from A, B, or D. And we change this from a product of sums to a sum of products. There are fast ways to do this. And then we measure the number of distinct terms here. The more terms that we have, the more anonymized we are. So that's in our numerator. That's N. And then the most common user is M. And in this case, the most common user is B, or I think B appears 3 times. And that's in our denominator. And so Q is the ratio of this. And as Q increases, that means N is big or M is small. N is the number of different possible sets. So that means you're more anonymized. Or if M is small, that means you're more anonymized, because the most common user is only in a small subset of these subset. And so Q grows accordingly. And so now we have a way to sort of evaluate for a particular anonymization just how effective is that. And therefore, Facebook could use this to develop Q policies. So in this case, if the Q exceeds some threshold, then you can choose to release the data or not, or you can ask users to develop sort of these kind of Q policies. So I'm just going to skip this in the interest of time and basically say we've been working on trying to build QAnon as a layer that's between you and the Facebook apps. We've tried to preserve the Facebook API so that it looks no different than a normal. So if your Facebook app queries QAnon, it looks no different than querying directly on the Facebook database. The only difference is that in the information that's returned to the Facebook app is filtered in some way and evaluated using QAnon. So we just built this piece. Okay, so to finish then, okay, so that covers privacy. to sort of finish a little bit on the infrastructure that I like to talk about for this mobile social vision. Social Fusion we envision as resting on top of existing cloud platforms like Azure and Amazon and App Engine. These are, I think, Amazon's infrastructure as a service because it's VMs fairly low level. We have Azure and Google App Engine as platforms as a service. And we envision this sort of whole Social Fusion mobile cloud computing framework, mobile social cloud, as sitting on top of that, and that next generation applications would hook into. And then in addition, we envision that there might have to be some mobile specific sort of modifications to the cloud. And in fact, Microsoft is already working on some of this. There's the MAUI framework, which is offloading complexity between the application and the cloud. And that's very useful for resource-constrained, energy-constrained mobile devices. Another piece of infrastructure is what I would call context-aware compilation. And the idea here is to make it easier in this new, brave new world of Social Fusion to build context-aware apps. And so how can we make it easier for developers to sort of develop components of this? And so the basic idea, or the observation, is the application is distributed into many small pieces. And so what we want is for the developer to very easily be able to sort of compose or specify their app, and that this gets compiled by a context-aware compiler into numerous small components that are then assembled together, maybe one for retrieving data, one for privatizing that data, one for mining that data, and one for actuating based on that data. Okay? So let me just conclude that what we've presented is sort of initial. We have not built this whole vision. We've explored pieces of sort of the mobile, social, and sensor vision, and I presented sort of a how we think it might look architecture that's layered, cloud-based, and tries to integrate privacy from the get-go. And I also talked about sort of mobile social group video, as well as social news, some of our initial efforts there, and also some of our recently published work on anonymizing social data using QAnon. So when Mike gets back from his internship here at MSR, my hope is that we can start sort of building out the actual pieces of this puzzle. Okay, so that's it. Any questions? Yes?
So nice job. When you were talking about group preferences, it was very striking that when you're looking at a group or a couple, right?
Yeah.
It's not just their individual preferences, but the whole experience sort of changes when you are doing an activity with a person, right?
Yes, absolutely.
For example, two people might like the movie, but they might not like watching a movie together. Right? Or two people like tennis, but they don't want to play the tennis together because their skill levels are completely different. Right? Or or a father or a son could want to watch the same movie, but differently, right?
Yes.
Not with each other.
Yes.
So that those sort of relationships, how would you sort of mine those relationships, and how you can? I mean, your work towards those specific rules goes into a direction,
Right.
but then the features that go into that those rules need to be discovered and built.
Right. Human context, that's an excellent question. Human context is incredibly tricky, and what we're hoping to do is, with sort of this initial foray into this area, is to extract maybe some general trends. But as you say, you may not want to play tennis with someone, even though it seems like you both like tennis, and you should be a good match, but in this case, it's not, right? And so it's an incredibly tricky thing. I don't know how much progress we can make, because there are always exceptions, or maybe the exception is the rule, and there are no trends that we can actually mine. But so we haven't done enough user studies really to tell us that there are these general trends that we can mine, and they'll work 70% of the time, but that 30% of the time there are all these small exceptions, that cause an incompatibility and therefore cause the recommendations to fail. So our hope is that there is that 70% case. So.
The other sort of related sort of work is on differential privacy. So
Yes.
there has been a lot of work on differential privacy.
Yes.
I was not very sure how that relates to
Yeah.
anonymity
Right.
work that you talked about.
Yeah, differential privacy, and I wish my student was here to sort of answer that better. But as I understand it, it's very statistical. And as you saw here, there wasn't really statistics that are involved here. This is a very bare bones, When a Facebook app is asking for your information, they're asking for specific information. And computing bounds on sort of the statistical noise that you might inject on the data, and so you can satisfy some bounds. I don't know if that really applies here. I can't say that it does not. But the other thing I would say is that these many times people inject noise. So what does that mean? That means they're perturbing the results. So it might say, instead of Avatar, Terminator, and it might say, the Barney movie or something, And so that will cause the recommendation systems to fail downstream, those apps. And so you can't really, it would be better, there are, I think, at least two major strategies for anonymizing. One is to withhold information, the other is to perturb it. And I think adding noise is not good for these kinds of context-aware systems. So that would be what I would say. A better approach would be selective withholding of information. And just give less information to the people rather than giving them deceiving information. And that'll work in a context-aware case. But so.
But the QAnon metric is exactly the same kind of approach as differential privacy. You appear in X out of Y things, therefore it's this identifying, and therefore if the query asks for information which is above a certain threshold, then you shouldn't give it to them. I mean, that is the same approach. It's just there are fewer statistics, but it's still a statistical approach.
Okay, it's still it's a numeric approach. I don't know if it's a statistical, probabilistic kind of approach. Right.
Maybe statistical rather than probabilistic.
Yeah.
About the
Yeah.
QAnon.
Yeah.
If you have this system which is filtering things based on, so, instead of I walk into a bar
Yeah.
and I tell the
Yeah.
bar my Facebook identity is so-and-so,
Right.
and then you go
Right.
off and it finds that information that I've said I'm happy to share
Right.
with any bar in the world.
Right.
Instead of that, you do this QAnon thing, and
Right.
then it says, what songs might you like to listen to?
Right.
What information do you get out of that, having put it through your QAnon layer, that you don't get out of just my phone saying, oh, look, there's a jukebox, why don't I send it requests? Because it seems like a lot of the strength of the approach is to infer things about the group dynamics and to know, therefore, oh, because these guys are such very good friends, we should use a different selection or algorithm or merging the playlists or whatever. But if you're passing your data through this QAnon thing, why don't I just send requests and keep all of my personal information on my phone and never identify myself to any third-party application?
Then you could never get any context, right? So, I mean, you want some trade-off, right? You have to give up something in order to get something. In this case, you're giving up some information to get some personalization. And all we're doing is saying, you choose some subset of the information to give up, right? And you get back something, right? And one of the interesting questions, actually, that this has thoughts that has spurred, is there are lots of different ways to anonymize, meeting a particular, let's say, Q metric, or it's whatever anonymization threshold you want. How do you choose which is the best one? Which one gives the most information content to the requester, right? Because here, 500,000 Facebook apps, some are games that are maybe not interested in certain sections of your profile, and others are, I don't know, some other types of, applications. And so you can choose to reveal information that is more relevant and yet still meets the anonymity metric. So how can you quickly do this also and scalably do this, I think is one of the interesting challenges, certainly that we ran into when we were trying to build this into Facebook, is how can we very quickly compute this anonymity metric scalably, and of all the different combinations of possible anonymization, which one gives the most information to the requesting app, but still preserves the whatever Q threshold you're aiming at. Okay, so that's an interesting question that we have not actually answered with this research. So.
But all the context that you're talking about, which is really helpful in terms of knowing not just that David and I like these songs, but knowing how you should put them together.
Right.
I mean, in order to, you say I can choose how much I want to reveal and get a certain amount of benefit, but in order to get any of that benefit, don't I have to reveal that these are the 12 people who I'm currently in a room with, and here's all of our social interaction with each other so that you can gauge how strong our tie is? I mean, that's a lot.
Well, our hope is that you don't have to reveal all that information in order to get something, right? So you reveal part of that information, and with QAnon, that's what we were trying to sort of characterize. But some of the earlier group work, which was separate, we were not considering, we were saying, let's give us all the information, and we'll do the best that we can, assuming that you divulged all that information. We haven't looked at the case where if you just divulged a subset of information, and then we were to run sort of these, social strength assessors, rankers, and other the user similarity rankers, how effective would that be? I think that's partly getting to your question, right? We have not been assuming, you get all that information and then you can make all these decisions and then you anonymize after that. No, it's like, we haven't looked at the case where, what if you filtered up front and then tried to run all of this context awareness? Would it just completely fail? So that's a good question. That's a great question. Okay, any other questions? All right, well, thank you very much. Enjoyed it.